All right, everybody, welcome back to my basement. I don't have access to all my stuff, so I'm going to do the best I can with what I have down here. I'm going to do a little bit of notes on the paper, and I'm going to bring the screen in and tip it up, and we'll just see how it goes. I'm going to be pretty mobile here. Now, I want to go back and talk about and finish talking about Darwin's observations. So he gets back in 1836, and the Queen summons him for a meeting, and she wants to know, what did you see while you're out there? Now, Darwin, being a science guy, he has three basic observations. So we can take that whole meeting and boil it down to three things. He said species vary locally. Now, if you said that to a regular person, and we did this yesterday, so I'm just recapping. If you said this to a regular person, like, no kidding, Scurby, there's lots of different species, but that's not what Darwin's point was in terms of the future umbrella of evolution. He said, no. He said in any local area, in one local area, and we're not talking about 100 yards, we're talking miles, 25, 30, 40, 50, 100 miles. In any one area, you can have very similar species. And I mean so similar that they're all the same. They're all the same. But there are fundamental differences. Fundamental differences. And yesterday, we did example one, was the Galapagos. Oh, misspelled that, sorry. The tortoises. Those are the giant turtles. And I showed you pictures, and there were two different shells. So if you don't have that in your notes, you can add that now. There were two different shells, and those shells were based on feeding. So Darwin is thinking, how do we get two different tortoises with noticeable physical differences and attributes 25 miles apart on two different islands? Now, at the time, he doesn't know. He's just making these observations. So if I bring my screen in here, there we go. It's not going to be perfect, but you can see in this one right here, we have a very shallow arc, and this one's called a saddle-shaped shell. And right at the end of the period there, you guys did determine finally, which was good, that this one right here has that cutout so he can extend his neck and reach vegetation that's much higher on his island. This one over here has a very low shell because this is very rich in low-lying vegetation, not a lot of trees, so he does most of his feeding in low areas. He feeds in high areas. So over time, their shells, and I'm going to add this word now. Darwin didn't say this. Their shells are very specialized. Now later, Darwin's going to say they evolved. And if you remember the third premise in his theory, they evolved from common ancestors. But over time, based on necessity, they changed. So that's pretty cool, all right? Now, I did want to include today, here's a picture. There kind of gives you a relative idea of how big these things are. I mean, that's no small guy right there, and that is a giant Galapagos tortoise. Pretty cool. Now, in South America, let me go example 2 here. In South America, there was another example, and we call it, they're very famous, are Darwin's, they're not actually Darwin's, by the way, finches. So in one localized area, Darwin found 4 finches. You guys are aware those are little birds, right? Okay. And those 4 finches are all different, yet still finches. So different species of a finch, and that's what he's saying. Species vary locally. So I have a picture of that for you as well. Let me drag that in. Oh, look at that. That looks amazing. There are the 4 finches. Now, I know you guys can't talk to me because I'm on camera, but if you look at those pictures, take a look. How do they differ? How do they differ? Oh, I know. How do they differ? Specifically, the correct answer is beaks. Their beaks in each species are specialized for feeding in their general area. And that brings up the whole point of ecology and microbiomes, or not biomes, micro ecosystems, where you have ecosystems inside of ecosystems, and the food chains and available resources are different. Now, Darwin doesn't know this at the time. He has an idea, and he's pretty experienced in the world of nature, but he hasn't put it all together yet. So number one, species vary locally. Number two, watch this. He also tells the queen, species vary globally. Globally. Now watch again. So let me bring this back in. This was variation in a very local area. So you could either walk, ride a horse, boat, swim, etc. in a localized area. But then he goes on to say, no. They also vary globally. So he says around the globe. Just making sure I was on camera. Around the globe. The whole planet. Watch this. There are similar species. That means you could go from continent to continent and find species that are the same. And here's the best part. In Darwin's mind, there is no possible way that could happen, because the amount of space between each continent is so large that these animals could not have made the migration across the open water. This blows his mind. I hope you're appreciating this. Okay? And his example are large, flightless birds. Large, flightless birds. Okay, now if you guys remember that picture of the trip yesterday when we were in class, he went to South America first. So I'm just going to write this across here. South America, that's SA, right? Then he proceeded to Australia as he was heading west from the Galapagos. And then finally, on the back end of his trip, they stopped twice in Africa. Okay, so South America, Australia, and Africa don't touch each other. Get a map out. They don't touch each other. Major oceans in between, right? So, you got the I'm not going to do the geography right now. So he found large flightless birds on all three continents. And he could tell all three, watch this, are related in his mind in some way. There's no other explanation other than they're related. And he starts thinking, how could they all be related? Where did they come from? How did this happen? Now, I'm going to show you a flightless bird, and then I'm going to tell you where it's from. These are the flightless birds that he found in South America. Now, you might be thinking, hey, Scurb, that's an ostrich. No, it's not. That is not an ostrich. On South America, there's a large flightless bird called a rhea, or rhea, R-H-E-A. That is the name of the large flightless bird that I just showed you. Then he goes to Australia, and he finds yet another large flightless bird. Now you can watch. Those look similar. I mean, not exactly the same, but similar. See that? Anybody know the one that's on the continent of Australia? Yeah, you do. It's the other red meat, the emu, or emu. I think it's emu, though. Then, on his way back home, I say that jokingly, he finds another flightless bird. Watch. Boop. Wow! Now, that's one you know. That's the ostrich. Let me put that right here. Sorry about the extra noise. He finds an ostrich. So I'm going to bring this back in here, and I want you to imagine that you're Darwin. 24, 25, 26 at this point. And you might be the first person in a continuous time period to find organisms on 3 different continents that are all similar. And Darwin, maybe, is the first guy thinking, how'd they do that? How'd that happen? We get the rhea, or the rhea, the emu, and the ostrich. 3 flightless birds, really big, 3 different continents. Darwin says, species vary globally. And that's a really good example. Now, you guys already, if a modern child, you know about Pangea and tectonic plates and the movement of the Earth's crust and the fact that the theory is that the continents broke up. And if you kind of look at the map, they kind of still fit together based on their shapes and where the plates are. Darwin doesn't know this. Plate tectonics is just starting to be an idea. We take all this for granted in 2020, but pretty cool. Number 3. Oh man, you're gonna love number 3. Let me get rid of this. So species vary locally. Species vary globally. Number 3. Species vary. Now here's where it gets a little hokey for him. Over time. I'm going to put a big block on that. Species vary over time. This is the root of evolution. When he gets back, Darwin is going to claim that species have changed. Species have changed over time. But they are still recognizable as ancestors and descendants of ancestors. What? What? Someone say, what? What am I talking about? Okay, watch this. In South America, Darwin finds a fossil. Now, you guys should already know in 8th grade that a fossil is the calcified remains of an organism that died and lived long ago. And through that calcification, the bones are preserved. They're not the bones. They're replaced with rock. It's really cool, okay? He finds a fossil, and that fossil has a name. It is the Glyptodon. Sometimes on the internet, you'll see it as the Glyptodont with a T at the end. They're both the same thing, though, okay? I want to show you this thing. I want to show you this fossil. Now, obviously, artists have rendered what they believe it would look like from its skeleton and, oops, I'll just leave that there, and the preserved nature. This, whoa, there he is. This is the Glyptodon. Look at it. Now, can anybody tell me what you think that looks like? Well, I know you can't answer because I'm on video. What does that thing look like? So that is the ancient one that doesn't exist anymore. It's extinct. This thing is extinct. Okay, leave me like, I don't know, 3 lines. I'm going to drop down here. So that's the ancient one. Let me come to modern times. Can anybody think of an organism that looked like the Glyptodont that actually lives right now, perhaps in the southwest region of the United States? Yeah, you know it, the armadillo. The armadillo. And I have a picture of our friend, the armadillo. There he is. Check him out. There's the armadillo. There's the Glyptodon. Armadillo, Glyptodon. Darwin believes, even at this point in 1836, that species vary over time. His claim is that this fossil could be, based on evidence, the ancestors of modern animals that have changed significantly but are still recognizable. And that's the key. You have this Glyptodont and the armadillo. Now, what I want to show you, just for fun's sake, is the relative size difference between a Glyptodont and an armadillo. Now, this is an artist rendition, but check that out. That's the modern version. That's the extinct version. And Darwin is claiming through evolution, this organism and its relatives, based on change over time, evolved or changed into this version. Now, how big is this Glyptodon? This is amazing. Okay, based on its skeleton, here's what they believe. Are you ready? I'm going to go right back to this section right here. It was about 11 feet long. 11 feet long. So are you picturing an armadillo? An armadillo is, at best 12 to 14 inches long and like 6 inches high. Pretty small. 11 feet long, 5 feet tall, and weighed in at a massive 4,400 pounds. Yikes. Can you imagine if armadillos that big lived in Texas? Well, they say everything in Texas is bigger, so that's actually a good joke. You can laugh at that. So Darwin says species vary over time. And this is where it gets good. Now, where do we go from here in the story? Darwin is home. He has reported to the Queen, turned over his evidence, all of his drawings, all of the resources. He's done his job. But now, Darwin is struggling. He is struggling. And he is struggling mentally. And what's he struggling with? Well, look at this. Darwin believes, well, he actually has evidence that species vary locally, they vary globally, and then based on fossil evidence, they vary over time, long periods of time. Okay? Now he's struggling. There's some issues here. He's got issues. 1, how old is the Earth? Because he's thinking this takes a long time, but if the Earth isn't that old, then he's 100% wrong. That's an issue. Number 2, how? What is the mechanism for change over time? He can't just say things changed over time. People, the first question out of a scientist's mouth is going to be, how'd they change? How'd this happen? He doesn't know. He has no clue of the mechanism. None whatsoever. So what's he do? He sits on it. I'm telling you right now. Whoops, I'm off the screen, aren't I? Oh, I'm sorry. Let me bring that up there. I'll let that sit there just so you can catch up. He sits on it. What is it? It is the idea. It is evolution. He thoroughly believes at this point in his life that organisms change over time. They did not just magically appear on the planet and stay the same for thousands of years. He doesn't believe that in any way. But he can't prove it because he doesn't have a mechanism. He doesn't have enough evidence. Ooh, there's an issue. Evidence. He lacks understanding, evidence, and a pathway to get there. So he sits on it. Well, how long does he sit on it? Years. Years. ... And the years tick by. Now, the next question in the story, well, what is he doing at this point? Okay? Because eventually, he's going to be the father of modern evolution and publish a book that absolutely rocks the thinking of their time. Rocks them. So what's he do? He's going to spend those years studying. He never lets go of the idea. Everything he does from now on until the book is published is fundamentally focused around this concept of evolution, that organisms change over time. And as soon as he understands the mechanism, he's ready to go. He spends time studying. Now, what we're going to do tomorrow, and I want to make sure I'm at school and I have my board because I got a lot of pictures and other things that I need to show you, okay? We're going to start looking at early influence. As is the nature with all major scientific research, studies, and discoveries, he didn't do it on his own. So I think it's important. It's not going to be on the PSSA, but I think it's important to take a look at the early influence on Darwin. Who were the great thinkers of his time that kind of molded and shifted his thinking to get him to where he needed to be to make this final publication called Evolution? Well, that's not the name of the book, but that's the topic of it. So tomorrow, we're going to start right there with early influence. And I'm going to bring up 5, I don't know if you can see my hand there. I'm going to bring up 5 important people and just specific little, scientific mental nuggets that nudge Darwin in the correct direction. And then I'm going to show you how he finally got there. And it's a really good story. At least I think it is. It's really cool. So that's all I have for today. I think there will be homework for the weekend. I'll get that ready tonight and be ready to post tomorrow. Other than that, I'm going to stop this video and then I'll be here to take any of your questions and we can talk about Darwin's observations. Peace.